Part A asks to find the common ratio of a geometric sequence that goes sine x, sine 2x, 4 sine x, cosine squared x, and where x is between minus pi over 2 and pi over 2. We know that the common ratio can be written as one term over the previous term. So in this case, we can take the second term, sine 2x, and divide it by the first term, which is sine x. We can simplify this a little bit more by simplifying the numerator using the double angle identity from the formula booklet. So we rewrite it as 2 sine x cosine x over sine x. And the final answer we get is 2 cosine x. Part B asks to find the set of values for x for which the series converges. A series converges when the r is between 0 and 1. So we can just replace r with the ratio, which is 2 cosine x. So now we have an inequality that we need to solve. We can rewrite each boundary separately. So we have 0 is less than 2 cosine x. So this means that cosine x has to be greater than 0. The upper boundary is 2 cosine x is less than 1. This means cosine x must be less than half. We know that cosine x is 0 at pi over 2 and minus pi over 2. Cosine is 1/2 at pi over 3 and minus pi over 3. We can graph cosine x in the domain given to us to help us find the intervals where cosine is between 0 and 1/2 easier. So now we can see that x must be between minus pi over 2 and minus pi over 3, or between pi over 3 and pi over 2. Part C considers when x equals arc cosine 1/4. Show that the sum to infinity of the series is square root of 15 over 2. The formula for sum to infinity of a geometric series is u1, so the first term, over 1 minus the ratio. This formula is not given in the formula booklet, so it's good to memorize it. We can use sine x as u1 and 2 cosine x for r. We then substitute arc cosine 1/4 into x, and now we simplify. The denominator simplifies pretty easily because cosine is the opposite of arc cosine, but the numerator is a bit more difficult. We can try rewriting sine as square root of sine squared. This is useful to us because we can now use the Pythagorean identity from the formula booklet to rewrite it in terms of cosine. So this is equivalent to square root 1 minus cosine squared. We substitute arc cosine 1/4 for theta. The cosine and arc cosine cancel each other out. Just don't forget to square the 1/4. And we get square root of 15 over 2 as our final answer, which was what we were meant to prove. So that's it for this video. Thank you for watching. I hope I helped you with this question, and please like and subscribe. Bye!